Alright, so we will, in this video, we'll work through the Chapter 1 practice test. And a lot of this content is things that are covered in earlier algebra classes like Algebra 1, but it's still a good idea to recap it. Okay, so these first problems are all about using what's called the order of operations. And this is the kind of the well-known acronym for how to use the order of operations. The point behind order of operations is if you have a problem like this, 2 plus 4 times 3. And the question is, should I add these first or should I multiply these first? Because if you try it, you'll get two different answers. And the answer that mathematicians came up with is PEMDAS. And this says do the parentheses first. Then if there are any exponents, do those next. Then if there's any multiplication or division, those are on the same level, do those next. And the very last thing you do is A and S, add and subtract. So these are all kind of the same problem. We'll do number 4 because 4 is probably the hardest one up here. And we just have, really the only thing is we have to be careful to copy this correctly. So A is equal to 6, so we're just going to go down the line plugging these numbers in. B is equal to negative 5. Okay, we have that minus there. And then we have this enormous parentheses. C times B would be 2 times negative 5, so we'll plug that in right there. Minus, and then that's B over 5. So again, B is this number. So negative 5 over 5. And then we have this inner parentheses here with A minus 6, and that's going to be 6 minus 6. Okay, so PEMDAS says start with the parentheses. We have a lot of parentheses here. Make a big, we'll outline that in blue. When we start with the innermost parentheses, that would be these two right here. So 6 minus 6 equals 0. And then this thing right here, well, there's nothing to do with the negative 5 in parentheses. Okay, now we can start to simplify this. So we have 0. We have a minus right here, and then these are being multiplied. So what comes first, subtracting or multiplying? Well, PEMDAS says that multiplication, the M comes before the S. It comes before subtraction. So that means we will multiply all this stuff together, and negative 5 over 5 times 0, that whole thing just equals 0. Okay, this right here, 2 times negative 5 equals negative 10. So let's rewrite this. So 6 minus negative 5 minus, and then parentheses we have negative 10 minus that 0. So negative 10 minus 0. Now we can simplify this. Again, PEMDAS says do the parentheses first. So let's deal with this parentheses here. We have negative 10 minus 0 equals negative 10. Okay, then we really just need to distribute this negative to the parentheses. So 6 minus negative 5 minus negative 10. Subtracting a negative is like adding 10. And that's true also for minus negative 5. That's like adding 5. So 6 plus 5 plus 10 is 11 plus 10. And that equals 21. So let's verify that, and there's the answer right here, 21. So that's a brief recap of PEMDAS. Okay, we'll do a couple more with fractions, or just one more with fractions. That's number 5. So number 5, we just have to plug these values in. So this is 1/2 times, this is 2, divided by, and then in parentheses we have B plus A, which is 1/2 plus, here's A. And I'm going to change A into a improper fraction. It's a little bit easier that way. So negative 1 1/3, what you do is take this number, multiply it by that, and add the 1. So 3 times 1 is 3, and 3 plus 1 is 4. So that's 4/3. And the negative just stays attached to it. So we're not actually doing 3 times negative 1. We're doing 3 times 1. Okay, so that means this A is the same thing as negative 4/3. Okay, PEMDAS says do the parentheses first. So in order to add fractions, we need a common denominator. And the common denominator for 2 and 3 would be 6. So 1 over 2, that's the same thing as 3 over 6. Negative 4 over 3, that's the same as negative 8 over 6. And just to verify where that's coming from, I'm multiplying the top and the bottom by 2. And for the 1 over 2, I was multiplying the top and bottom by 3. Okay, now let's keep going. So 1/2 times 2 divided by, we'll add these in parentheses, 3 over 6 plus negative 8 over 6 would be negative 5 over 6. And then what do we do first here? We have a multiplication, we have a division. Those are actually in PEMDAS, those are on the same level of importance. So this is how I wrote it before, because these occupy the same level of authority. So when you're faced with a decision, you just go left to right. So left to right would mean starting with this, half of 2, half times 2 is 1. And then we are dividing by this fraction, and dividing by a fraction is like multiplying by the reciprocal, which means we flip negative 5 and 6, and it doesn't matter where the negative is, whether it's with the 6 or the 5. 1 times that number is just that number. It's just negative 6 over 5. All right, number 6, 7, and 8, we have to simplify, or 6 and 7 at least, we have to simplify these by doing what's called combining like terms. And think of it this way: if you have 8 b's and you subtract 2 b's, or you have negative 2 b's, you add 8 b's, you're just basically adding these numbers right here. Negative 2 plus 8 is 6, and those are attached to the b. So all we do is add those numbers in front, and we have our answer 6b. This one's a little bit trickier because we have all these parentheses here, but when you see a number in front of parentheses, usually you just distribute. So 6 times 8 is 48, 6 times 4x is 24x. We still have this plus right here. 8 times 5 is 40, and 8 times negative 4x is negative 32x. Okay, now we want to do something called combining like terms, and like terms basically means that the numbers are like each other, so we can add those. 48 plus 40 is 88. And the things with x's are like each other. So 24x minus 32x, 24 minus 32 is negative 8x. So that would be our simplified answer. We cannot combine 88 and minus 8x because one of them has an x, one of them doesn't. So they're not like terms. Alright, these are like terms, so let's combine those. This is equal to 3r2 minus 1 is just 1. And then the way that we solve equations, we see what's being done to the variable, we do the opposite. So there's two things being done. First, it has the plus 1, so the opposite would be subtracting 1. So we're going to get 3r equals negative 11 minus 1 is negative 12. And then we see what's being done to r. It's being multiplied by 3. We do the opposite, which is dividing by 3. So we're going to get those cancel, and we'll get r equals negative 12 over 3, which is equal to negative 4. Okay, same idea with these. The only difference is now we have some fractions to deal with. So let's start by combining these right here. 5 over 4 minus 5 as a fraction is 5 over 1. And to make a common denominator, the common denominator would be 4. So we need to multiply both of those top and bottom by 4. 5 times 4 is 20, and 1 times 4 is 4. 5 minus 20 is the same as negative 15 over 4. So here's what this becomes. This is negative 43/12 is n plus this number. Okay, plus negative 15 over 4. And instead of saying plus negative, we can just say minus, because those are equivalent to each other. See what's being done to n and do the opposite. N is being subtracted right now, so the opposite would be adding 15 over 4 to both sides. And then we have these cancel, and n is going to equal this thing right here. So let's figure out what that is. Negative 43 over 12 plus 15 over 4. Once again, we need a common denominator here, and the common denominator would be 12. So I can make that into 12 if I multiply it by 3. That becomes negative 43/12 plus 3 times 15 is 45, and 4 times 3 is 12. Negative 43 plus 45, that's equal to positive 2 over 12. And 2 over 12 reduces to what you see right there, 1/6. Number 10, we have to again use a distributive property with this. So we're going to get 28 plus 4v equals negative 2 times 1 is negative 2. Negative 2 times 3v is minus 6v. Okay, the idea with this, because we have numbers and variables on both sides, we'll put all the variables on one side, all the numbers on the other. It doesn't matter how you do that, but it's usually easier to add the variables rather than have subtracted that 4v, although it is a matter of preference. Okay, so we're going to add those. We'll have 28 plus 4v plus 6v is 10v. And now I need to move this number over. So minus 28. Okay, so let me just clear that so we have some more space. So we're going to get this. We have those cancel. We have 10v equals this. Equals negative 2 minus 28, which is negative 30. I see what's being done to v. It's being multiplied by 10. So I do the opposite, which is divide by 10. And v equals negative 30 over 10, which is negative 3. And that's the answer. Okay, these are done the same way. This time we have to distribute on both sides. So let's do that. So negative 5 times both of those. Negative 5 times 2n is negative 10n. Negative 5 times negative 1 is positive 5. Negative 5 times that will be negative 5n minus 25. Okay, let's move this stuff over. So let's add the 10n to both sides, and those will cancel. And then we want to move that 25 over also, so that the numbers are on one side. So 5 plus 25 is equal to 30. Negative 5n plus 10n is 5n. We see what's being done to n. It's being multiplied, so we would do the opposite, which is divide. And n equals 30 over 5, which happens to be 6. Okay, you could always check these answers too by plugging that number back in for n and see if you get it. Alright, one more, same idea, so let's distribute the negative 2, so that negative 2 times 6 is negative 12, negative 2 times 5b is negative 10b, or minus 10b, same thing. 2 times 6 is 12, 2 times minus 3b is minus 6b. Let's move all of these b's to a single side, and then we will move all the numbers to the other side. Negative 12 minus 12 is negative 24, and then negative 6b plus 10b would be equal to that right there, 4b. And then we divide by 4, and negative 24 divided by 4 should be negative 6. Alright, last couple problems here from 1.4. This is on absolute value equations, and the idea behind absolute value is that if you have a number and it's equal to, let's say, the absolute value of that number is 8, there's two numbers that meet that condition. There's two numbers that on a number line have a distance away from 0 of 8, because absolute value distance is always positive. One of those numbers is 8. 8 is 8 away from 0, but so is negative 8. So when you get to this point, when you get to the point where there's nothing there except the absolute value, what you can do is split this into two equations where x equals the positive version of that number and x equals the negative version of that number. Okay, you can only do that when there's nothing left except the absolute value. So if you take a look at 13, there's not nothing except the absolute value. There's the absolute value where there's that 4 in front, and the 4 is multiplying. So in order to get the 4 away, we need to do the opposite of multiplying, which is dividing by 4. Those now cancel, and we're left with absolute value 3x equals this number. 48 divided by 4 is 12. Now it looks like this problem. Now we have nothing there except the absolute value. So we can split this off. And the question is, what are the two numbers, because there are two numbers that do this, what are the two numbers that are that far away from 0, that are 12 away from 0? And the answers are 12 and negative 12. So we'll divide both of these by 3. And 12 divided by 3 is 4, and negative 12 divided by 3 is negative 4. So that's why those two solutions are written. By the way, that's not a coordinate. It's hard to see, but it's like a curly brace right here. So these are not x and y. Those are both x values. Okay, I don't want you to think either that it's always going to be 4 and negative 4, or like 10 and negative 10. That will be the case for 13 and 14, but not for other problems. Alright, on 14 we cannot split it until this 6 has gone away, so it's being added, so we'll subtract it. So we have absolute value 5k equals 36 minus 6 is 30. Now we have nothing there except the absolute value, so we can split it off. And there are two numbers that have an absolute value of 30. One of them is 30, one of them is negative 30. If we divide everything here by 5 on both sides, 30 divided by 5 is 6, and negative 30 divided by 5 is negative 6. So those are our two solutions. Okay, right here we have nothing outside the absolute value, so we can immediately split it into two equations. Okay, we cannot, some people would want to try adding 5. You can't do that. You have to get rid of the absolute value first. So 3n minus 5 equals positive 14. 3n minus 5 also equals negative 14. And now we solve it by adding 5 to both sides. Same thing over here. So negative 14 plus 5 is negative 9. 3n equals that. And over here 14 plus 5 is 19. And we'll divide by 3. There's one solution. We divide this by 3. Negative 9 divided by 3 is negative 3. And 19 divided by 3 is just 19 divided by 3. You could also change that to 6 1/3, but you don't have to. Okay, last one for this page, and we'll pick up in the next video the rest of it. So again, here we have nothing except the absolute value, so we can immediately split it into equal to 19 and equal to negative 19. And then let's do this. Let's add 6 to both sides so we can get rid of the minus 6. So we're going to have 5n, those cancel, is equal to 19 plus 6 is 25. And over here, 5n is equal to negative 19 plus 6, which is negative 13. And our last step is to divide by 5. So in this case, we have n equals 25 over 5, and that's equal to 5. And then n also equals negative 13 over 5. In the last video, in the next video, which will also be the last one, we will finish this practice test with a couple more absolute value problems, and then sections 1.5 and 1.6 also.